How do we prove this trigonometric identity? You can either show that the left hand side is equal to the right hand side, or that the right hand side is equal to the left hand side. I want to show that the right hand side is equal to the left hand side. Right hand side is 2 cot theta into bracket cot theta minus cosec theta close bracket plus 1. Now how do we show that that's equal to 1 minus cos theta over 1 plus cos theta? What do I do? Okay, let me write this as 2 cot theta, 2 cot square theta. Let me open the brackets first of all. Minus 2 cot theta cosec theta plus 1. I've just opened the bracket here by multiplying everything inside it by 2 cot theta. And that's equal to, let's see, I know that cot theta is 1 over tan theta. Cot theta is 1 over tan theta, which is the same as 1 divided by sine theta over cos theta, because I know that tan theta is sine theta over cos theta, and that's the same as 1 times cos theta over sine theta, which is cos theta over sine theta. Let's see. Okay, let me do that. 2 cot square theta will now be 2 times 2 times, I know that cot theta is equal to 1 over tan theta, which is cos theta over sine theta. So that means cot square theta will be cos theta over sine theta cos theta over sine theta all square. Yeah, the square of cos theta over sine theta. What do we do next? Minus 2 times cos theta over sine theta multiplied by, what is cosec theta? Cosec theta is 1 over, let me even write it this way, times, write as 2 times cos theta over sine theta times cosec theta, which is 1 over sine theta plus 1, and that's equal to 2 cos square theta over, that's 2 cos square theta over sine square theta minus 2 cos theta over sine square theta plus 1. Let's see. So what do we do? Let's find the LCM. This is 1 over 1. So if you find the LCM of all of the denominators, that's going to be sine square theta. Sine square theta divided by sine square theta is 1 times 2 cos square theta times 2 cos square theta. That will be 2 cos square theta minus sine square theta divided by sine square theta is 1 times 2 cos theta. That will be 2 cos theta plus, this is 1, sine square theta divided by 1 is sine square theta times 1, that's sine square theta. So we have sine square theta here, and that simply means 2 cos square theta. 2 cos square theta. I can see that the numerator of the left hand side doesn't have sine in it, it has cos. So that's why I'm going to change this sine square theta to 1 minus cos square theta. So this will be 2 cos square theta minus 2 cos theta plus 1 minus, I'm changing this sine square theta to 1 minus cos square theta all over sine square theta. The left hand side doesn't have sign in it at all. So I'm going to write sine square, the denominator sine square theta, as 1 minus cos square theta, and that's equal to 2 cos square theta minus cos square theta. That's 1 cos square theta, which is simply the same as cos square theta minus 2 cos theta plus 1 all over 1 minus cos square theta. Now where do we go from there? This is a quadratic expression which can be factorized. If I make cos square theta x, that means x square minus 2x plus 1. If x is equal to, sorry, if I make cos theta x, if x equals cos theta, that means cos square theta minus 2 cos theta plus 1 will now be x square minus 2x plus 1. How do we factorize that? That's going to be x square minus x minus x plus 1, which is x into bracket x minus 1 minus 1 into bracket x minus 1, which is x minus 1 times x minus 1. And I can write that as the square of x minus 1. And I know that x is cos theta. So that means the numerator is the same as cos theta minus 1 all square. X minus, the square of x minus 1 will now be the square of cos theta minus 1. We just replace the x in that with cos theta. So that means the numerator is the square of cos theta minus 1 divided by 1 minus cos square theta is actually a difference of 2 squares. So which I can write as 1 plus, because that simply means 1 square minus cos square theta, which I can write as 1 plus cos theta times 1 minus cos theta. And that's the same as, let's see, that's the same as, what can I do? I have cos theta minus 1 as the numerator, the square of cos theta minus 1 as the numerator, and the denominator I have 1 plus cos theta times 1 minus cos theta. Okay, that means I can do this. If I factor minus 1 out of this, it becomes minus 1 into bracket minus 1 minus cos theta, which is the same as, okay, let me even do this. No, I should write the numerator first. The numerator is cos theta minus 1, the square of cos theta minus 1, divided by, I want to find a way to write one of the denominators as cos theta minus 1. So this one is 1 plus cos theta. Let me leave this one as it is, 1 plus cos theta. Now it is this one I'm going to write as 1 minus cos theta. I can write it as, that's times minus 1 into bracket 1 plus cos minus, is that going to be minus 1 is like 1 plus cos theta minus 1. If I bring out minus 1, I'll be left with, no, if I bring out minus 1, this will be minus 1 plus cos theta. Yes, if we factor minus 1 out of this is what I'm going to have. And you see that if you expand this, you get 1 minus cos theta. Yeah, that's it. That's the correct thing to do. So that simply means I can now say cos theta minus 1 all square over this minus 1. I can bring it outside there. I can write as minus 1 into bracket 1 plus cos theta. I'm just bringing this minus 1 here since it's multiplication. A times b times c is the same as a times b times c is the same as a times c times b, or b times a times c, however you choose to arrange, it's still the same. So minus 1 will be here, and I have this 1 plus cos theta, and I'll be left with this minus 1 plus cos theta, which is the same as cos theta minus 1. And that simply means I can say cos theta minus 1 cancels one of the cos theta minus 1s here, because this is actually, maybe I should even show that this is cos theta minus 1 times cos theta minus 1 all over minus 1 into bracket 1 plus cos theta times cos theta minus 1. Cos theta minus 1 cancels cos theta minus 1, and I'll be left with cos theta minus 1 over minus into bracket 1 plus cos minus 1 into bracket 1 plus cos theta, which is equal to, now I can take the minus 1, multiply the, of course, plus divided by minus is minus. That's the same as minus into bracket cos theta minus 1 over 1 plus cos theta, which is simply the same as, if you open the brackets at the numerator, we're going to have 1 minus cos theta plus 1 over 1 plus cos theta, which is the same as 1 minus cos theta over 1 plus cos theta. And that's the same as, let me be sure, is that what the left hand side is? That's the same as the left hand side, 1 minus cos theta over 1 plus cos theta, which is equal to the left hand side. And that's the proof, very, very simply. Let's take another one. Prove that sec squared theta, prove that sec squared theta minus cosec squared theta is equal to tan theta plus cot theta times tan theta minus cot theta. This should be a piece of cake. Let's see. Let's show that the left hand side is equal to the right hand side. Left hand side is equal to sec squared theta minus cosec squared theta, and I want to show that that is equal to the whole of this right hand side. So that will be equal to sec squared theta is 1 plus tan squared theta minus cosec squared theta is 1 plus cot squared theta, and that will be equal to 1 plus tan squared theta minus 1 minus cot squared theta, and that means 1 minus 1 is 0, so we are left with tan squared theta minus cot squared theta, which is a difference of two squares, and that simply means tan theta plus cot theta times tan theta minus cot theta, which is the right hand side. And how that was quite cheap. We go to the next one. Show that sine theta over 1 minus cos squared theta is equal to cosec theta, and that's supposed to be an easy one too. Left hand side is sine theta over 1 minus cos squared theta, and that's the same as sine theta over 1 minus cos squared theta is the same as sine squared theta, and that simply means sine theta divided by sine theta times sine theta. Sine theta cancels sine theta, and I'll be left with 1 over sine theta, which is cosec theta, and that's the right hand side, which is equal to the right hand side. And that was a piece of cake. Now, let's take another one. The next one, show that 1 minus sine theta times 1 plus sine theta divided by sine squared theta is equal to cot square theta. Is equal to cot square theta. Let's go from the left hand side. The left hand side is 1 minus sine theta times 1 plus sine theta divided by sine square theta, and we want to show that that's equal to cot squared theta. What do? This numerator is the same as 1 square minus sine squared theta. So that means 1 square minus sine squared theta over sine squared theta. I can write 1 square simply as 1. And this simply means I know that 1 minus sine squared theta is cos squared theta, because sine squared theta plus cos squared theta is equal to 1. So the whole of this will become cos squared theta over sine squared theta. And that's the same as, let me even write it this way, cos theta over sine theta, the square of cos theta over sine theta, which is simply the same as the square of cot theta, which is written cot squared theta, and that is the right hand side. And that's the right hand side. And that's it, very, very simply. Let's take just one more. Prove that the square root of 1 minus cos squared theta all over cos theta is equal to tan theta. Let's go from the left hand side to the right hand side. The left hand side is the square root of 1 minus cos squared theta all over cos theta, and we want to show that that is equal to tan theta. I know that sine squared theta plus cos squared theta is equal to 1, and sine squared theta is equal to sine squared theta. Sine squared theta is equal to 1 minus cos squared theta. 1 minus cos squared theta, and that simply means sine theta itself will be the square root of 1 minus cos squared theta. So that means this numerator is sine theta. So that's sine theta over denominator, which is cos theta, and that is the same as tan theta. Sine theta over cos theta is tan theta, which is the right hand side. And that's it, very, very simply. Just make sure you know the basic trigonometric identities, and you'll be able to find your way around proofs.